What is going on with this? DVR 360 close cache. Yeah, everything's good. Hey Matt, how are you? Sorry about this, guys. Can you just see like just like the corner of my screen here? Or can you see the whole thing? Hey Lexi, how are you? So, man, something happened here, and I thought if I just reset the stream key, it would actually work. But, yeah, if all you can see is like the top left-hand corner of my screen, this is a problem. Oh, okay. All right. So it's just the preview window then. That's doing something. Sorry about that, Morgan. I didn't mean to kick you out of the other one. It's just something's going on with the preview window on the YouTube side here that I have no idea. It's never done that before. I might have clicked a setting or something. I don't know. As long as you can see everything, it's fine by me. So welcome back. What are we doing today? Oh, let me copy the link here. And then we will dive into some stats. What's our trivia topic for the day? Astrology? Yeah, sure, we can do astrology. I don't know that much about it, so I'm going to have to find a site here. I mean, other than like, what's the animal associated with, cancer or something like that. We can find something, though. Let's see. Yeah, that one's cool. I've never done astrology before. Oh, there's quite a few sites. All right, cool. We'll be able to pick one. Yeah. Let's see. Oh, it's not giving me answers. It wants me to take the quizzes. Let's see. Here we go. About this. Nope, that one's on the quizzes too. Oh, here's a bunch of them. All right, cool. Yeah, no, we'll do that. That's fine. Marvel, that's a good one too. We'll do that one on Monday. Yeah, we always do comic books at some point in time, whether it be Marvel or DC or both of them kind of lumped together. Definitely not an area of expertise of mine, but I know we can find some good stuff out there. And so I will keep that one in mind for Monday. All right? Let's see. Yeah. No, as long as everything's working, we'll get started here. So I just gotta find a website that does it. Oh, never mind. Okay. Yeah, this one's all right. This one works. Dark Horse? No, not really. That's kind of that's a little esoteric. I mean, we could do it. Yeah, I mean, Google's totally fine, so it's not like we can get too far into the weeds. But that one, I'll have to go find a couple questions on it though, because not terribly familiar. Yeah, no, comics weren't really my thing when I was growing up. I was always a computer game and Nintendo game kind of guy. That's what I spent all my money on when I was growing up. I mowed a lot of lawns for my first NES. A lot. So I didn't spend money on comic books back then. So I mean, that was back when there's like, well, I guess they're still around. But I mean, going to the comic store was like a treat, you know. Yeah, I'm sure everybody would be using Google on that one. Yeah, no, we can do that, or we can do like a comic day or a comic week or something. Yeah, that's fine. I like we did one last fall that was like comic print strips, so like classic Sunday funnies kind of stuff. Start quizzing them on the Commodore 64. I had a Commodore 64. It had 2 games when I got mine. So actually, that was my dad's. So but I was allowed to play with it sometimes back in the day when I was trying to teach myself how to do. Oh, I know, it's completely. Yeah, I mean that is so long ago. So we had a Commodore 64, and then we had an Amiga. And then, yeah, we started doing the PC thing. Our first PC was a Commodore Colt. Oh my gosh, yeah, that was a long time ago. And then the 286 and the 386 and the 486 and the P1 and oh my gosh, yeah. So we had all the things, and we're not even talking about game consoles, and I even have half of them when I was growing up. So we had the NES for a long time, and then. I think the first one that we got, I think we had a Genesis before anything else. But then, like, I have a friend, and he still has his TurboGrafx 16, which, I mean, that cost a bloody fortune back in the day. And so, oh, I know, yeah. And then he's got a couple of the rare ones. He's still got a GameCube. He's still got his Dreamcast. It doesn't work very well. I mean, we can get it. If we sing it to sleep at night, sometimes it'll still run. Actually, no, I don't think he has that anymore. I think he gave that away to somebody. Yeah, who was really appreciative. But no, we've had them all. Between us, we've got them all. So back in the day, I mean, even had the what was it? We even had a Sega CD for a little while. Yeah, that thing was a piece of junk. I mean, some of the games are pretty fun, but that thing was a piece of junk. So, anyway. Yeah, I have a Genesis in my closet over there still. That thing will never die. So, yeah, you get the Game Boy Color. I had the Game Gear, the Sega version. Actually, it wasn't mine. It was my brother's. But we used to play Sonic on that like crazy. So that was a long time ago, man. I remember those things came out. Anyway, let's talk about stats. We'll do astrology today. Yeah, but let's hop into Alex here. And I'm going to put this over here so I don't dox you guys here real quick while I log into this, because I get to see your progress on my initial screen. And that's not for you. Let's check it out here. Here we go. Man, some of you are doing great. There's a few of you who, I mean, we're only on week 3 of the course, and you're probably a good, 16-week course. So, yeah, some of you are a good third of the way through the class, and maybe a little bit more. That's really good to see. And so, let me just show you guys the class average here, which is this guy right here, and that is looking really, really good. So we have quite a bit of ways to go. I'm about halfway through the oranges, I think. I've got a few of these left, but we'll cover oranges today. We'll do more oranges next week. And we'll definitely do Chevy Chev next week. So if you've run into that problem, that one is kind of a pain. Yeah, Donkey, that was an original rare game. That was a really good one. So, yeah, with DK and who was the little guy's name? I can't remember now. So, but we're going to get through the oranges here this week, next week, and then we'll start focusing on the reds. And so if you're already pushing into the reds, you're ahead of me. That's great. If you're stuck on a couple of the orange ones, now's the time to start speaking up and saying, hey, can we cover this problem? because I will absolutely, I'll get through them all, but if you've got one that you're jammed up on right now, I'd be more than happy to cover it for you. All right? Diddy, thank you. Yeah, it was Diddy Kong. You're right. Yeah. So you remember the little alligators with the teeth? So that was an excruciating noise, but that was a rare game. What was the other big one they made? Oh, that was for the 64. They made GoldenEye, and I was just reading the other day that they actually got really close to re-releasing another one and pulled the pin on it. So it'd be good to see that one because I had a 64, and of all the systems that I had, I think we probably got the most mileage out of the 64, and that was largely due to GoldenEye. Yeah. So, but anyway, let's dive in here and let me show you where I'm at on these things. And then again, if you have any topics that you want me to cover today, start punching them in there. I'll see them. All right. But we'll do trivia here in a little bit too. Let's just let's get into some of these orange ones here real quick and see what we still have. Now, I still haven't gotten a knowledge check yet, so and I'm quite a ways through these. So 19, and I think I don't know. So I have 10 of 19, so we're about halfway through the oranges. And like I said, there's a couple at the end, tail end of the oranges that are a little bit more involving, and so we'll spend a little bit more time on them. And if you've pushed into the reds, you notice that sometimes after like some of these easy ones in the orange, the problems do get a little bit longer. And so the other day when we were doing histograms and polygons, frequency polygons, those do take a little bit longer to do. When you get down into these, some of these problems will take quite a bit. So, like, there are a few topics we'll spend almost the entire day on one of those topics. And so we're going pretty fast right now. But just understand that, yeah, if you get jammed up on these, now's the time to save time. All right. And so if there's one or something that you're a little bit messed up on, we'll definitely cover it. Okay. All right, see, it's already throwing reds at me. We're not going to do any of those. So let's, unless you want me to cover one for you, but let's go ahead and here and jump into the oranges. Now, one thing that I did want to cover was standard deviation, but I also noticed that there's quite a few of the ones in here that we do need to kind of clean up a little bit. And so I think we'll spend time on those this week, and then next week, since the Chebyshev problem is directly related to standard deviation. We'll do the standard deviation ones on Monday. Unless you're jammed up on one, just let me know. But other than that, I was going to clean up a few of these, like this percentile, cumulative distribution and ogives. Let's do that one real quick because this one is very, very easy once you realize what you're looking at. All right. And so in this one, if you get the one previous to it that had the frequency and relative frequency, or it's like interpreting relative frequency histograms, then that's exactly what it's giving you right here. But what we're going to do is we're going to create what's known as a cumulative percent polygon, or an ogive is what they call it. I've heard it pronounced both ways, ogive and ogive. Okay, so I don't know. But it's basically we create a graph, all right? Using this graph, we're going to create a new one that has a cumulative frequency line on it, a polygon on it, and they're very, very easy to do. Sometimes people just get a little bit jammed up on where to start with these, and so you'll create a graph that looks like this. And so, yeah, I mean, you can read all this, but these are actually pretty easy to figure out, okay? So in order to do this, we're going to use the data in here, and notice this one is frequency, and so it'll still say one of two things. It'll either say cumulative frequency or frequency. If it says frequency, you got to do a little bit of extra math in order to get the proportion, because this graph here is proportional, and so it'll be based upon the percent. All right, and so you'll notice that right off the bat, because when you click and drag these up, it's a percent, not a count. Okay, and so these are pretty straightforward. Little hack for you on this one: these are pretty easy to get wrong because some people don't know where to start. This one, whichever one's always way over on the left-hand side, is always set to 0, and this one over here is always up to the top. And so now the trick is to actually figure out how these work, and we're going to use the calculator for that. And so this first one, notice that it corresponds 40 with 40 right here, and so it's 13 out of 100 respondents. And so this one's actually pretty easy. We're just going to take this up to 13, okay, because 13%. And so to get the next one, we take this, add this, and then divide it by that. But since it's out of 100, we don't really need to in this one, but some of the ones in the future we will. So in this one, all we have to do is take 13 plus 28, add them together, we get 41. And so this one's going to be at 41, like that. And then we just add the next column, which is 21. Okay, and that's going to be at 62, like that. And then this one here, 62 plus the next column, which is 16, 78. Take it up right like that. And this last one, add the last column, second to last column, which is 12. Okay, which gives me 90. And then you can kind of use this last one as a checksum. So 90 plus 10 would be 100, okay? And so that really helps with these. Just remember this last one will always be at the top, this one will always be at the bottom, and then just make sure you don't get jacked up on the columns. They're always going to correspond like this, 56 less than 56 less than 52. Hope that makes sense, all right? Let's see if we get the other kind here where it's a frequency. I don't know. Maybe they don't do them like this anymore. They used to do them where sometimes it was a relative frequency, but looks like it's giving us the actual frequency. Notice this one's out of 50, so yeah, we're going to have to do a little bit of math on this one. So pretty straightforward. This one down, this one up all the way. So this is cumulative frequency right here, so it's not relative frequency. And so actually we don't have to do that much math on this one because this one's asking for the actual count, not the relative frequency. All right. So I think they do have ones in here that are relative frequency, but we'll have to see. So in this one, it just corresponds to whatever is to the left of whatever this particular value is. So 600, 600, that's going to be 8. So take that up to 8. Like that. So 650, 650, everything less than that. 8 plus 11 gives us 19. Okay, and then this one here, so I'm not going to do the math all in my head. Everything less than 700, so it's going to be 19 plus 15, so 34. And this next one here, add 12, because that's my next column right there. Bam, it's 46. And then my checksum, 46 plus 4 gives me 50. Boom, we're good. All right. All right, one more. Here we go. Cumulative relative frequency. So this one we have to do a little bit different math. But no, actually we don't, because this one gives us as relative frequency. I think in the past, Alex used to kind of like throw multiple curveballs at you. It might still, I don't know. All right, but sometimes you do, it gives you the frequency and you have to figure out the relative frequency. Just remember that extra step to divide by the whole on each one. Hope that makes sense. So how about this one's pretty straightforward. This one is 0, this one all the way up to 1. Okay, and then this first one right here, .24, so bring that up. .24, just getting that number from right there. The next one is going to be .24 plus .32, just the next column. Okay, oops, not times. .24 plus .32. Gives me .56 for this one, 56. Add the next column, which is .28. Gives me .84. Bring that up, .84. And then the next to the last column, add .08. Gives me .92. .92, right like that. And of course, use this last one as a checksum. So 92 plus 8 gives me 100. Okay. Ta-da. All right, so that one's easy. After you do the other two and it unlocks this one, you can knock this one out in like 5 minutes. All right, so piece of cake. Here we go. Yay! Let's see if it's gonna give me. No, I'm on thin ice here, man. So they're gonna give me knowledge check here any minute. All right, so I want to save these standard deviations for Monday, and so let's just knock out the rest of these here as quickly as we can. So population sample, so that's 3. So we'll do 1, 2, and then percentiles here as well. Let's do this one here, but let's do a trivia question first. All right, so percentiles, this is one that people do get jacked up on, and so I want to go over, in this one in a little bit of detail. All right, so but let's do astrology trivia. So here we go, starting with an easy one. How many signs are there in the zodiac? How many signs are in the zodiac? So, and remember, they don't correspond exactly, the way that you think they do. All right, but how many signs are in the zodiac, the classical zodiac? Did anyone play the GameCube Sonic where you had chaos? Yes, I did. So 12, yes, you got it, Jake. You got it first. So there are 12. Even though there are 12 months in the calendar, of course, they don't line up just quite right. But I think the signs in the zodiac aren't they based No, they never change. But isn't there like one or two that are a little bit longer or shorter? Because I thought the whole thing was based upon the lunar calendar. I could be completely wrong. Or it says or 9, huh? So in some cases there's only 9. I didn't know. So depending on which one you're talking about. So I guess we're talking about the classic one here. So yeah, it's I don't know what you mean by that, Lexi. So elaborate for me, please, because I've never heard of 9 just in there. But anyway, yeah, I played the GameCube Sonic where you had Chaos, and then what was the other one? I think it was Sonic 2 on the original Genesis where you had Tails. So you had Sonic and Tails in that one, and I think you could go both play co-op at the same time if I'm not mistaken. Yeah, yeah. Oh man, you guys are making me walk down memory lane today. Sonic Adventure 2. Okay, all right. So anyway, let's talk about percentiles. So a lot of people get confused on this one because they read this description and the description kind of stinks. All right. I always jack this one up a little bit too, but what you're basically doing is you're given a data set here, okay? And then you're asked to find the particular percentile based upon what it's actually giving you, okay? The formula for this is really, really easy, okay? So all you do is take your percentile, so .25, and then multiply it by how many are in the data set. And so like this one, .25 times 17. Okay, so 4.25, you always have to round this up. This is one of the two problems in Alex where you always have to round up to get the nearest whole integer, the next highest whole integer, let me put it that way, not the nearest one, the next highest whole integer, and then you're just going to count, all right? After you put these in order, you're just going to count to that 4.25 or the fifth number, and that fifth number in the data set is your 25th percentile. You're going to do the same thing for whatever else it gives you, okay? So the formula is really, really easy. Sometimes people look at this and are like, wait a minute, what's N and what's P and blah, blah, blah. Don't worry about it too much. We're going to skip this divided by 100 thing and just put in P as a decimal and then multiply it by N, which is the number of numbers, observations in the data set, okay? And then we're just going to count. Here, let me show you how to do this real fast, easy breezy. So what is the probability of Rockies having a competent management? It is 0. It is 100. Okay, so it is, yeah, no, I'm sorry, it's 1. In that case, I can't believe they actually made that trade the other day. So, Evan, anyway, let's get back onto this. Here we go. All right, so 10th and 75th percentile. So the 10th percentile is going to be .10 times how many numbers are in the data set? 19. Okay, 1.9, round that up to the next whole number, all right, which is 2. So I'm going to send my data to the calculator. Well, actually, let me clear that out. Send the data to the calculator here and hit sort. All right, sort the data so it's in order, and it's going to be my second number, so 196. Okay, it's that easy. All right, next one, same thing. All right, so 75th percentile, I'm going to take .75 and multiply it by 19. How many are in the data set? 14.25, so round that up. All right, so which is going to be 15. So it's the 15th number in the data set. All right, so here we go. Sort. I could count from left to right 15 times, or there's 19, so I can just count back 4, and it's going to be the same number. 1, 2, 3, 4, 252, right there. Okay, check. Oops. 75th percentile is incorrect. Uh-oh. So let me clear that out. Send it to the calculator. Sort. It's 19, 17, 16, 15. 252? Did I do it right? .75 times 19. 14.25. Yeah, unless they change this. Because it used to be the nearest whole integer. All right, let's try the next one. So because this send data to calculator button is a new thing, so they might have changed a couple things in here. Let's try 249. Recheck. Yeah, okay, so that whole thing that I said about rounding up, don't do that. Round to the nearest whole integer. Okay, so it used to always be rounding up, but I guess not anymore. Okay, so you can ignore that thing that I said. So here we go. Let's just test it. 30th percentile, so .3 times my n, which is 17. There we go. 5.1, so it's going to be number 5. Number 5. Unless I jack something up on that one. Oh, not store. Sort. There we go. 1, 2, 3, 4, 5, which is 41. Okay. And then a 75th percentile .75 times 17 gives me 12.75, which rounds up to 13. And so let's just send the calculator sort. I have 17, 16, 15, 14, 13 right there, 50. Let's see if this is right. Check. Yeah, okay, so yeah, don't round. Don't always round up, all right? Oh, I know the sort button is your savior. It'll save you so many times in this class, all right? So that it is absolutely wonderful. I completely agree with you on that one. So you might be thinking of the Chinese calendar. I think the Chinese calendar has only got 9 in it. It's been a long time since I looked at that. I was actually married on Chinese New Year, and so it's interesting because like our anniversary changes every single year if we go by that. Otherwise, we just go by the actual date. So anyway, here we go. 30th percentile, 75th percentile with 19, and so .3 times 19, so 5.7. So my 6th number on this one. Send the calculator. Sort 6. 1, 2, 3, 4, 5, 6. 315. And the 75th percentile, so .75 times 19, 14.25, so my 14th number. Send sort, and there's 19, so 19, 18, 17, 16, 15, 14, which is 609. 609, check. There we go. All right, yeah, don't do that rounding thing that I told you about before. Other than that, you can be all right on this problem. All right, next. Let's see. Sketching the least squares regression line. Nah, we don't need to do that. So back to descriptives. So once you do that one, percentiles, those 3 are on that. This one takes a little bit of time, so let's go ahead and do that one. And then we'll take a break, and then we'll finish up with box and whisker plots today, which are a pain. All right, so but this one, making reasonable inferences based upon proportion statistics. A lot of people get screwed up on this one because it's just a logic problem, but at the same point in time, you have to read it really carefully. And so a lot of times in ALEKS, you don't really need to read the stuff. But then every now and then, it's like, yeah, you absolutely have to read this extremely carefully. Okay, and so here we go. Let's just dive right in. All right, records of computer retail stores show that out of the 100 customers who purchased desktop computer last month, 74 also purchased a service plan that extends the warranty for an extra year. Out of the 25 customers who purchased a notebook computer last month, 17 purchased the same service plan. So out of 100, 74 did purchase. Out of 25, 17 did purchase. So always take a look, because sometimes it'll say they did not, okay? So, and then you're doing a little bit slightly different math. I'm sure we'll get one. So last month, customers of the store who purchased desktop computers were less likely to purchase the service plan because only what percent of them purchased the service plan? All right. So desktop 100 out of 74, out of that 100. So this is 74% here. Notice I'm not putting them in order right now. I'm just going to do the math on them first. And then with our laptop notebook computers, it was 17 out of 25. So 17 divided by 25. So that's 68%. All right. So this is important because read the problem now. Desktop was more likely because they purchased 74%. Notebook was less likely, so they purchased 68%. So I got these in here backwards. All right, so this one's going to be 68, and we're going to change it to notebook. This one's going to be 74, and this one is going to be desktop. All right, and then just read through it again real quick just to make sure. Customers store notebook computers less likely. Only 68% of the notebook customers purchased the plan, whereas 74% of the desktop customers bought the plan. All right, check. Okay, so again, it takes a little bit of time, right? Because these are really easy to jack up, and I almost guarantee you that I'm going to do it. So you never know. I might thread the needle today. 100 people given product A, and all but 27 experienced relief. In the same study, 25 were given product B, and all but 3 experienced relief. Product A, so notice this. It says all but 3. all but 27 and all but 3. And so we got to do a little math here, okay? And so think about this, because it's asking us which one actually got people who got relief, not the people who didn't get relief on these, okay? So be very, very careful with these. All right, so I always just punch one in and then do the math on it. Product A performed worse on the study. All right, so product A, all but 27. So the number who actually did was 100 minus 27, or 73% got relief. Whereas product B, all right, so was 3 out of 25. So it was 22. Oops. There we go. So it was 22 out of 25 did get relief because 3 did not. Okay, or 88. So product B is better than product A. So product B is our winner. And this one's going to be 73. And this one here is going to be 88, because 73 corresponds with product A. Sorry if it seems like I do those a little bit backwards, but I always get jacked up on these, and so I just punch one in, all right? Then I do the math as I go through, and then if I need to, I switch them afterwards, okay? It's just the way my brain works sometimes. All right, so check. Oh, boo, what did I get wrong? So the value of the percentages is incorrect. It was only 88% got relief. Oh, I got them backwards. See, look at that. I didn't need to change them. So I'm looking for the one that actually performed worse. And so it was A was 73. See, I told you. I mean, self-fulfilling prophecy there. And this is 88 with B, right? Check. There we go. Oh, god dang it. Now I got to do 2 more of them. Boo! All right, 50 males used a weight loss supplement, and all but 11 of them experienced weight loss. Same study, 20 females used the supplement, and all but 3 of them experienced weight loss. Was less effective. All right, so less effective is the same as did not, right? Yes. So the new one is less effective on, we'll just say males in the study, because what percentage of males lost weight? So it's 50 and all but 11, but it's asking them for the people who did lose weight. So 11 divided by 50. So nope. It's 50 minus 11 divided by 50. There we go, 39. So 78% of them did lose weight, whereas the females, 17 out of 20. 17 out of 20 lost weight, or 85. Okay, was less effective on males because only 78%, whereas 85% of the females. Yes, all right, that should be good. Good, there we go. So, yeah, I know the proportions and the way that they're worded is just, it's a pain. And I'm sorry, but Alex is going to do that to you a few times. This isn't the first time it's going to do it. All right? So just go slow, double check before you move on to the next one. And if you trip up on one, don't get too frustrated with it, okay? Chances are you probably know what you're doing. You just, you missed like one word in there. It said yes when it meant no, or it said not when it said meant did, And so just be careful with it. All right, Bumblebee. That's not a comedy. Moviegoers were asked in a quick poll. Well, I guess it's comedy. So whether they liked the movie. Out of 25 adults, all but 8 said they liked the movie, whereas 50 teenagers, all but 10, said they liked the movie. The movie brothers, I think it's going to be adults. Stop ringing. Like the movie less, because how many of them disliked the movie? See, it's asking for how many disliked. So out of 25 adults, 8 out of 25 disliked it, which gives us .32. Whereas teenagers, it was 10 out of 50, or .2. So 20% of the teenage moviegoers disliked the movie. All right. So movie premieres, adult moviegoers liked the movie less because 32% said they disliked it, whereas only 20% of the okay, all right, I think that's good. All right, cool, Dunzo, yay! Oh, good, we don't have to do that problem again. Well, except for on the quiz. So, unless you get trivia questions right, which, speaking of which, I think it's time for another here. Yeah, we're going pretty fast today. Yeah, I want to save these for Monday, so we'll do box and whiskers because these are a pain. All right, they're not too bad once you start doing them. All right, but they can be kind of a pain. But anyway, astrology trivia number 2 coming up. What sign does the archer represent? So in your zodiac 12, there is an archer. Which sign is he associated with? Go for it. Which one is the archer? So, which one is the archer? For a free quiz, a free chapter quiz. Morgan, you got it? Yep, it is Sagittarius. But did you get the previous one right? No, that was Jake. All right, good job, Morgan. You were able to sneak in there. So just a fraction of a second faster than guts, right there. All right, but yes, it's Sagittarius. Good. Oh yeah. Well, see, Lexi. I mean, spelling does count, but you know, in this case, it's speed that matters most. So I appreciate it though. But good job there, Morgan. You got it. All right, so remember, in this class, you only get one, all right, each week, unless we make special exceptions for that. Oh, it's your sign, so that was easy. Yeah. So, like, what is my... I think I'm Capricorn, and I think that's the goat, if I'm not mistaken. So, I couldn't tell you any of the other ones except for the crab is Cancer. I don't know why. I know that one. I think Pisces is pretty easy, too. Isn't that the 2 fish... kind of thing. Yeah, just because, you know, what is it if you're a pescatarian? Isn't that somebody who just eats fish, if I'm not mistaken? Yeah, okay, yeah. All right. All right, so here we go. Box and whisker plots. Now, these are very, very common in stats, and folks use them a lot, particularly when you want to get a good idea of what the distribution of a data looks like, of a data set looks like, just in an instantaneous glance. All right. And that's because a box and whisker plot, basically we're going to draw out this distribution here without actually doing all the individual observations. We're just looking for 5 specific observations, okay? The minimum value, the maximum value, the median value, and then what's known as the first quartile and the third quartile. Actually, those might be the other way around. I don't know. So actually, this one's the first quartile. This one's the third, right? I can't remember. It's one way or the other, but that's all you're looking for. So with these, and then you draw this one out, okay? And so you can do this on a number line. I find that it's easy to do in the Alex calculator. There's also some websites on Blackboard that will do it for you as well. But I don't know. I think they're just kind of faster to do them by hand, all right? Because what I like to do is take the data, open up your calendar, send your data to the calculator, and sort it, all right? This will make life way, way easier, all right off the bat, okay? And so this one and this one are the easiest ones, so they're the ones that do this, your lowest and your highest values, so 35 and 69. So this one's going to be 35. Take that all the way down, and yes, sometimes, I mean, it's really tempting to just do this, okay, but notice like 69, our highest data value on the number bar here is 70, and so it's actually a little bit down. And of course, Alex does that just to make sure that you're paying attention on these, okay? All right, so the next one you want to do is their median value, which is the middle value. So out of 18, all right, so it's going to be at 9.5, all right, because you just take that number and you divide it in half. All right, and since there will be 9 numbers on each side because it's an even n, it's an even number, okay, our median is not actually represented by an actual observation in the data set, okay, so it actually sits between number 9 and number 10, so there's 9 on either side, okay, and so just go in here, count over 1, 2, 3, 4, 5, 6, 7, 8. See, I lost count, so it's 46. 1, 2, 3, 4, 5, 6, 7, 8, 9. 47 and 55. So it's between 47 and 55. So clear this out. 47 plus 55 divided by 2. Oops. 47 plus 55, 102. Split that in half. There's your median right there. Okay, so this one's going to be on 51. Right there, okay? Now to figure out this one, clear this out again. This is actually a little bit easier now. Okay. And send your data to the calculator. Hit sort on it. Okay, and think about this, all right? So between here and here, there are 9 figures. There are 9 numbers, right? 18 overall, so there's 9 on the left-hand side of this one, and there's 9 on the left-hand side of this one. So you just need the median of those 9 on either side in order to figure this out. Okay, and so of the 9, since that's an odd number now, okay, this got a little bit easier on us. It just means we need the 5th number. Okay, so because there'd be 4 on either side of it, and that is, since it's odd now rather than even, all right, and the next problem we get, it'll probably be the other way around. All right, we actually, the middle value, the median value between the median and the minimum value is actually represented by a number in the data set, and that's just going to be the 5th one over 1, 2, 3, 4, 5, 38. There we go. Bam. So 38, and then this one, same thing on the other side. There's 9 numbers on the other side of this guy, and so it's going to be the 5th one from the end. 1, 2, 3, 4, 5, 60. Right there. So I think that's the easier way to do it. And watch this, I'll get it wrong. I sure did. Minimum is not correct. Oh my gosh, I got everything right except for the minimum value. So it's 35, and I put it at 35.5. I just a little tap on that one. Just need a little tappy tap. It would have been fine, but just not paying attention. Anyway, I hope that makes sense. Let's do another one. Here's one. It's got 17, which is an odd number, so our median value is going to be easier to find on this one. Send the data to the calculator. Hit sort. My top value, highest value, my max is 60. My min is 23. So we'll do those first. 23. And 60 is all the way out there. Okay, my median value is 17. Okay, so it's going to be my 9th number. All right, so think about that. All right, so it's going to be number 9. All right, because there'd be 8 on either side. Okay, and that 9th number in the middle, add that all up, it's 17. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 36. So you go on 36. And notice it scooches that other one down. I don't think it used to do that. That's kind of cool. All right, so the next one, all right, since there's 8 numbers on either side, it's going to be in between your 4th and your 5th number. So 4 on each side, so it'd be in between 4 and 5. All right, so here we go. 1, 2, 3, 4. Okay, 5. Notice that it's the same, so we don't even have to do any math on this one. It's 27. Okay, so... and if you really want to do that, just take this, add that, divide by 2. Guess what you get? That. Same thing on the other side between our 4th and our 5th number. 1, 2, 3, 4. So it's going to be between 52 and 55. All right, so 52 plus 55 divided by 2 gives 55, 53.5. There we go. There we go. Oh my gosh, yeah. Just be careful how you click on this. It's kind of sensitive. Okay, check. Got it. Whew. One more. Here we go. All right, next one. Send data to the calculator. Sort. Maximum value is 82. Minimum is 51. So 82. And down here, 51. Got it. So how many of them are there? 19. And so we have an odd number. And so our median value is going to be in the data set. And so it's going to be between number 10 and 11. Okay. 1, 2, 3, 4, 5. No, it's going to be number 10. Sorry, my bad. It's actually represented in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 61. There we go. There's our median. Okay. And so that leaves us with, what is it? 8 on either side. Yep. And so it's going to be between number 4 and 5, just like last time. So here we go. 1, 2, 3, 4, and 5. So it's going to be between those two. So 54 plus 57. 57 divided by 2. This one's going to be 55.5. I hope these make sense. All right. Sometimes you just have to practice them a little bit. But once you get used to the idea of calculating median, it gets really easy. Okay. And so this one over here, 8 numbers on this side. So let's take our data, put it back in the calculator. And it's going to be between number 4 and 5, working from right to left. 1, 2, 3, 4, and 5. So 75 and 78. 75 plus 78. Oops. 75 plus 78 divided by 2, 76.5. So that's way over there. Okay, and so interpreting these is pretty easy. You know this is your median value, and you know that there's something in the data that's stretching it out this way. Okay, even though this one's your median value, you've got some outliers out here that are absolutely making your data a little bit wonky. So because if your data is perfectly distributed, these look very symmetrical. Once you see wonky boxes in here or long lines, you know that the data is a little bit skewed. That's why you use box and whisker plots in the wild. All right, if you do any stock trading or anything, like every website where you track stocks will actually do, box and whisker plots on a daily value for a stock, and that will be the range of different prices that stock traded, and you look for ones where you have like a tail that goes way down like this or way up like that, because that's what actually indicates some kind of movement in the market. Yes. No, it's not a rule as far as fourth or fifth goes. It's how many numbers there are in the data set. So see, like this one has 19 numbers, okay? And so if I split that evenly, all right, so I'm going to have 8 numbers on one side, 8 numbers on the other side, and 1 number in the middle. So, or I'm sorry, 9 numbers and 9 numbers, okay, on either side, and that 10th one is in the middle. So 9 plus 9 is 18, plus 1 more gives me 19. All right, so it's that middle value. All right, it's got to be even on either side. And the same thing's true for the third quartile and the first quartile. So think about it. In this case, since I have 8 on the one side, okay, it's going to be between 4 and 5 because I got to take that 8 and split it in half, and so I got 4 and 4. I don't have anything left over, so it's in between those two, and so you have to do a little bit of math right there. And that would be true if it's like 17 numbers, then it'd be 6 and 6, okay? Or then it'd be 8 and 8 and 1 in the middle. If it was 14 numbers, it'd be 7 and 7 on either side, which means that there's no middle value. So it's just, remember, you have to split it evenly between both sides. And whenever you have an odd value, okay, you're going to be left over with a 1. You're going to be left over with one single number that's your sweet spot. But when you have an even amount, whether it be on the other side or the entire data set, then that's when you have to split it, and then you have to do the math to figure out the value in between those middle values. Hope that helps. Okay, I know it's a little tricky to explain, all right? But if you do get jammed up, oh my gosh, I jacked one up here. So first, you guys are probably sitting here watching me explain all that and checking my math, saying, oh, you screwed something up bad. God dang it, now I got to do another one. First quartile and third quartile are not correct. Okay, so maybe I counted this wrong. So 19 is going to be 9 on either side. So it's going to be, it's going to be my exact 5th number, right? No. It's going to be 9 on either side. So it's going to be between 5 and 6. Gosh dang it. Yeah. No, it's going to be my 5th number, right? Oh my gosh, now I'm screwed up on this. I talked myself into a circle. All right, so let's just try it again. So first quartile and third quartile, all right? And so 19 leaves me with 8 on either side. So it's going to be between my 4th and 5th. 1, 2, 3, 4, 5. And it's 4th and 5th. Oh, sorry, my bad. 4th and 5th. I bet you, yeah. Okay. 1, 2, 3, 4, 5. So between 54 and 57, right? 54 plus 57 equals divided by 2, 55.5. That's what I got. All right, so let's try it the other way. 61 was my median. So clear this, send the calculator. Sort. 61 was my median right there. Okay. 1, 2, 3, 4, 5. Maybe it's between 5. It's maybe between 5 and 6 on this one. No? 1, 2, 3, 4, 5. Yeah, let's try it. Oh my gosh, I jacked the whole thing up. Screw it. Explanation time. I I guess I'll be doing more of these. I'll do those off camera. So what is it? 55? It was 57. Yeah, because the 57s line up there. 1, 2, 3. Oh, you know why that was? Because, yeah, 61 fell on... Oh, man, that's kind of a tricky problem then. Yeah, because there were two 61s. Oh, yeah, no, okay, so that changes things a little bit. Because, yeah, if you use a number line like this, you'll always get it right. I was just trying to do it a little bit faster. So one of the ways that you can do is take this, put it in the calculator, or write it out, all right, so as a number line, and then just stroke mark your individual numbers off. So that's kind of the old school way to do it. But at the same point in time, let's see, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I was thinking the median was right here, but it was on that second 61. Watch out for that, okay? Because that would jack up both this one and that one, and so yeah, it would have benefited me to actually write that one out, but that's okay. At least you got to see me screw it up. All right, so you don't make that mistake. If you do get really jammed up on these, all right, the other thing you can do is go over here on Blackboard. Go to course modules and then go to descriptive statistics module 1. There are 2 box plot generators on here. This one I think is a little easier to use. But it has a flaw in it, and there are problems that you will get wrong because this one consistently rounds down, okay? And so if you get that one, sorry, there's really not another way around it. This box plot generator here does not do that, okay? But this one's kind of a pain because you got to type everything in there, okay? And it's not like where you can copy and paste because it'll put things in like this, 66, 67, comma, okay, something like that. This one doesn't want any spaces in between individual ones, okay, and whereas the other calculator does. But this one will always get it right. You're just going to have to do a little bit of data entry on it, all right? And then when you actually do it, so let me just make one up here real quick. I don't even think you have to put these in order, so if I'm not mistaken. So you could just type it in directly, but it'll actually create the box plot for you. So here's your third quartile, here's your first quartile, here's your min, your max, okay? So you can do it that way too. That's absolutely fine if you want to do them that way. I mean, we never draw these by hand out there in the wild. Every software package that we use in statistics will do this work for you. And so if you can use something like this, you can also there's calculators, like the stats calculator if you had it in the previous class. I know it's not required for this class, but it should have a function on there that actually does some graphing, and box plots would be one of those too. I can't tell you how to do that in a calculator, though. You'd have to Google that. All right. So anyway, yeah, okay. So let's get out of this and call it good for the day. We're just about at the hour-long mark here, and so I owe you one more astrology trivia, and if there's any questions you want me to cover, all right, now's the time to make them known so I can cover that topic here. Even if it's something I've already covered, that's absolutely fine. If there's something you jammed up on, punch it in there now, and then we will use the last few minutes of class for questions here. All right. Anyway, speaking of questions, let's do another zodiac one here. Oh, here's a great one. If you were born on Halloween Day, what would your sign be? If you were born on Halloween, what would your sign be? That one's great. Oh, this is the other one that I know. So if you're born on Halloween, what would be your zodiac sign? So what would it be for a free quiz in the class? It would be what? Nope. No. Yes, good job, Lexi. It is Scorpio, the actual scorpion, the other sign that I know what the animal is. But yeah, it would be Scorpio. You're saying Libra, huh? Okay, so we got a little bit of disagreement on this. Maybe this site is wrong. All right, so Halloween, spelling, Halloween zodiac sign. Scorpio. All right. Google settled it. So, yeah. I don't know. When is Libra? So, yeah, no. So, Halloween is what? October 31st? Yeah. So definitely Scorpio right there. All right, so good job, Lexi. You got it. Yay! Good job. All right, folks, that's all I got for you today. If you have anything that you want me to cover, any questions that you have, I'll stick around here for a few more minutes. Other than that, you feel free to log off. Have a wonderful weekend, and we'll catch you all on Monday. I hear that we're supposed to have like another nice day or so of weather, and it's supposed to get a little cruddy, but you know, I mean, it's February, it's Colorado, it's kind of what it does. So, but enjoy the weekend. Keep up the great work. You're doing a great job in this class, and ping me if you get jammed up on anything. I'm here for you. All right. All right. Probability involving two mutually exclusive events. That problem sucks, and yes, I'll be more than happy to help you with it right here. 22nd, I heard someone say they were Libra. Oh, okay. Maybe you should Google that. I don't know. I don't know what my daughter's sign is, actually. So you bet, Morgan. Take care. If you got a quiz today, email me. All right? But I'll do probability involving... Yeah, you bet, Eric. No worries. I'll do probability involving two mutually exclusive events here. This is definitely one that we'll be doing a longer video on in the future, but I can help you through this. You bet, Matt. Take care. All right. So I got to go back into teacher mode here in order to do this one because I don't have it unlocked yet. At least I don't think so. No. So yeah, it'll make you do like Venn diagrams first, and then there's several of them. So if you're on this one, you're pretty far ahead, and that's really good. So I'm really proud of you. But this one, there are two problems that are an absolute pain. In Module 3, this is all Chapter 5 stuff in the book. Hang on, I just got to switch between screens here so I can log in real quick without showing everybody else's grades, which would get me in trouble, rightfully so. But let's go into the pie here, and I will show you that problem. All right, so probability. With these, there are two problems that are a pain in the butt. And so this one, probability involving two independent events. If you don't do this one until you do probabilities involving two mutually exclusive events, okay? Because if you try this one without doing this one first, it's way more confusing, all right? You'll get confused on this one if you do this one first, and if you do this one before you do this one makes a lot more sense, all right? So anyway, here we go. Yeah, okay, so I've got a hack on that second one I'm going to show you in a minute because I am guaranteed to get that one wrong every single time. Oh, okay, you too, Lexi. Take care. So, but mutually exclusive, what mutually exclusive means is that when one occurs, the other cannot occur, okay? So in these problems, you're going to have like 3 or 4 different ways they can come out. One occurs, and the other does not occur. Neither of them occur, or one does not occur, okay, which means the other can occur or nothing can occur, okay? I hope that makes sense. It's hard to kind of visualize these in some way, but just remember in these problems in particular, you can never have both of them occur. So there's no intersection, okay? It's not possible. It's either or it's off, so to speak, okay? So compute the probability that A occurs but B does not occur, okay? So this is just A, all right? So that would be the probability of just A because we have A occurs, okay? It says that right there. You can completely ignore this B does not occur because you know if A occurs, B does not occur. Hope that makes sense. Mutually exclusive. The best way to think about it is coin flips. Okay, if you get heads, you're not getting tails. Okay, so which is completely different than independent events. All right, and so compute the probability that A occurs without B occurring. So A occurs, or A and B both occur. A and B both cannot occur. So again, this one is just A occurs. All right, so it also says or. That A occurs without, so this is just A. Yeah, actually these ones might be the exact same. All right, so .55 on both. Let's just take a look. Yep, .55, .55 on both. All right, so even though these problems are worded differently, it's exactly the same, all right, because you just really have to ask yourself, it's going to be A is on, B is on, or nothing is on, okay? So, because there's some in here where it's like A occurs, B does not occur, and then B occurs and A does not occur. That would just be everything else, okay? All right, let's do another one here real quick. So we walk here, we compute the probability A occurs but B does not occur. Again, just A. All right, so you want to know, hey, does A occur? You know that it can't occur if B does. All right, so that one's just A. All right, it's very straightforward. It's .01. That either A occurs without a B occurring or A and B both occur. Exact same problem that we just got last time. You just have different probabilities on this one. And so see, it's just A and A. All right. Now that's pretty rare. You got two of those in a row just like that. So let's do another one here real quick. A and B are mutually exclusive. A occurs with probability .29. B occurs with .09. A occurs or B does not occur. And sometimes you see this one or both do not occur. And so this one's a little tricky. All right. So it's A plus everything else except B. And so it's 1 minus B. Okay. Because it could be A does occur, or, and that's the key right here, or B does not occur, or both. Okay, so because again, it could be A does occur, A does not occur, so it's A plus everything on the outside. Hope that makes sense. I like to draw these out personally because I think about it a little bit and it says, okay, A occurs, color in your A, and then it says, or B does not occur. Okay, so that means B is off. But it also means that it could be everything else. All right, so there you go, because it could be the occurrence that neither of them actually do it. That either B occurs without A occurring or A and B both occur. And so this one's not possible. Whenever it says A and B both occur, not possible. Okay, and so this one is just B in this case. Check it out. See, that's what I meant by that. All right. And of course, the mathematic way to do that is just 1 minus, whatever B is, because that's the only thing that's left. That's the easiest way to do it. Okay, but then this one, just be careful on these. All right, 9 times out of 10 it's just asking you for 1. Okay, these are the ones that you have to watch out for, and that's your key phrase for that is whenever it says that. Okay, does that help? I hope so. I mean, they're a little bit trickier to do if you've already gone through all the Venn diagram ones, and the one where you actually do them mathematically, they're a little bit easier. I find them a little bit easier to do mathematically. And so these ones I can usually figure out what it's trying to say, but the other ones, this one, probability involving 2 independent events, I get this one consistently wrong every single time. So let me show you how I like to do these. I mean, I'll run through the entire explanation. They're pretty straightforward, but some of these formulas get really complicated because you have the intersection. And of course, the intersection between the two, okay, of course, is just the probability of A times the probability of B. And so there are times where you have to leave it in there. There's times where you have to back it out, like this one right here. And quite honestly, my brain just, oh man, it hurts. All right. And so everybody's allowed to use this. And let's see, I need to go back to this one here. Oh, wait, did I lose my other window? No, module 1. There we go. Go to course modules. There it is. Jeez. Okay, module 2, probability. List of formulas for independent event problems. If you have more of an algebraic mind like I do, click on that. Here's all the formulas. Okay, we collected these as a class a couple years ago and agreed to write them all down. And so just match up the language, and then here's your formula right there. It'll make life way easier, and you'll be able to crush this problem out so much faster. Because really, when it comes down to it, you're not going to see this stuff again. All right, so mutually exclusive is important in terms of like some of the stuff that we're going to do down the road, because you're going to have mutually exclusive outcomes and things like that. But probability, we're going to move into distributions really soon and use the probability distribution more so than we're actually going to use any of this logic stuff. And so this will help you get through it. Okay, just use the sheet. All right, sometimes they don't match up exactly, so it'll be like computer A and B, and it'll switch the A and B. It's the same thing here, just make sure you switch the formula. Okay, just rotate them out, and most of them you don't have to worry about that. Okay, hope that helps, Eric. Are we good? Got any other questions? All right, You bet. I'm seeing everybody drop out of here, so I'm gonna assume you're cool. All right, I'll stick around for another 30 seconds or so, but at the same point in time, have a wonderful weekend. Hope that helps you, and also at the same point in time, good job. You're pretty far ahead, so good on you. Keep at it. All right, awesome. I'm glad to hear it. All right, guys. We'll catch y'all later. Take care now. You too, buddy.